apprentice to the great Merlin, and I am packing for a journey on which he has asked me to embark. Now, being an apprentice wizard, it's fair to say that strength is not my strong suit, and therefore I'm unable to carry anything but this small box and the knowledge that resides in my mind. Now, unfortunately, I find myself having forgotten my wand inside Master Merlin's office, and I cannot pack it until a later date. Nevertheless, I do know how long my wand is, and therefore, after some calculations, I can save a space big enough for it inside my box, if I calculate that it does fit at all. I shall do this with an ancient mathematical theorem, often falsely attributed to the extraplanar philosopher Pythagoras, although it is probable that the Babylonians were using it 1,000 years before his time. The theorem of Pythagoras essentially states that if you cut
A rectangle
in half diagonally, thus creating two right-angled triangles, and draw a square along each side of the original rectangle, the areas of the two squares you've just drawn will add up to the area of the square that uses the diagonal cut as a side. In mathematical terms, taking the letters a, b, and c to refer to the sides, a squared plus b squared equals c squared. You may have heard this before. Take this triangle, for instance. We know the theorem will only work if it has a right angle, so let us measure them presently. Because the angle between b and c is a right angle, or 90 degrees, we can use Pythagoras' theorem. Because we know that side b is 5 units long, and side c is 12 units long, and that this triangle has a right angle, we know that the squares of the two shorter sides added together will be equal to the square of the length of the longer side which is also known as the hypotenuse. So, a squared equals b squared plus c squared. A squared equals 5 squared plus 12 squared. A squared equals 25 plus 144, which gives us a squared equals 169. All we need to do now is take the square root of 169 to give us a equals 13 units long. Now, in the next lecture, I'll expand this theorem into the third dimension. Until then, I wish you wisdom, knowledge, and balance.